Hi, my name's Arthur Vickers. I'm an engineer at Microsoft working on Entity Framework, and we're going to be talking to you today about 𝗦𝗲𝗀𝗀𝗀𝗀 Evolving Data Access in .NET, and I'm joined by James. James, you want to introduce yourself?
My name is James Kovacs, Director of Engineering at MongoDB. I work in database experience, which builds our drivers and client tooling.
Great stuff. And we're going to be joined later on by Shay, who's going to do some deep dive into some nitty-gritty details of 𝗦𝗲𝗀. But for now, let's get started. So what are we going to talk about today? Okay, so we're going to start off at 0 and go rapidly to 100 miles an hour. But don't worry, because we're going to come back down again when James does his MongoDB, and you're going to be able to follow along with some code quite nicely there. So we're going to start off by just saying, okay, at 0, what is Entity Framework for? And then when we've talked about what it's for, we want to specifically look at how this applies to relational databases. So we're going to look at Azure SQL, and we're going to look at Postgres, and also document databases. So we're going to look at Azure Cosmos DB for NoSQL and MongoDB. And as part of this, there's going to be a bunch of slides at the beginning with some little demos, but then, like I mentioned, we're going to have a big demo from James on the MongoDB provider, and then Shai's going to join us a little bit later on and talk about AOT compile queries. Okay, so what's EF for? So EF Core is to help developers. More specifically, it's to help developers leverage common patterns for data access. So what do I mean by that? Well, for example, if your application uses change tracking unit of work, and James is going to demonstrate this later, then that behavior is a common pattern that is essentially the same regardless of what kind of database and what kind of database system you have. You're going to do the same kind of thing either way. For modeling relationships, it's a little bit different because modeling relationships is different on a document database than it is on a relational database. But at the same time, there's a lot of common ground here and a lot of common APIs and patterns that we can use. And of course, you want to write link queries, and they have to be translated into SQL or MQL if you're on Mongo, for example. So this is not intended to be an exhaustive list. This is just a few examples of what EF helps developers do. But more importantly, EF's goal is to utilize the power of each specific database system. So where a database system is good at doing something, then EF Core should allow you, in fact, even promote you to use that as a best practice within that database. So for example, Postgres has array mapping by default. So when you're using EF with Postgres, it should do array mapping. Azure SQL has temporal table support. So if you're doing version tables, you want to be able to do that really nicely in EF Core, and so on. And the list goes on. There's very interesting ones around document databases that we're going to cover later on. Okay, so that's what EF is for, which is all, you say, fairly obvious. But this is why I went into that in such detail, because I want to talk about what EF is not for. It does not provide a common abstraction over any database. So if you remember what I said, EF behaves differently against different database systems, right? So EF is going to use arrays on Postgres, and it's going to use something else on SQL Server. And because of this, then it means that we haven't chosen a lowest common denominator behavior. We haven't chosen a behavior on one database and said, let's make all of the databases behave in that way. So it means you can't just drop in and replace an EF Core provider and expect your application to work in exactly the same way. It's not designed that way. However, what we're going to show you is that you can, with a different EF Core provider, leverage a lot of common stuff across all different types of databases, systems, and applications, and then do the specific things that are specific to your database system where you want to really take advantage specifically in that case. So we've got kind of motto that we've been using on the team recently, which is embrace your database. So the idea of this motto is, we're not talking about EF Core as a, hey, forget about your database. You don't even have to care about it. It is abstracted away. It's not a concern anymore. EF Core is not for that. What it's for is it's making it easier to really embrace what your database does well and make it easier and better for you to do that in your applications. Okay, so how are we going to look at this? So we're going to look at Mongo in a demo later, but before that, what I'm going to do is I'm going to look at some example features, and I'm going to show you how those are utilized in different database systems. So what EF Core does with them for different types of database systems. As I mentioned before, we've got two relational databases, Azure SQL and Postgres, and we've got two document databases, Azure Cosmos DB for NoSQL and MongoDB. Okay, so the first set of changes that I mentioned this at the beginning beginning, these are things that are basically going to be the same regardless of the database system you're using. These are behaviors that EF has layered on top of the database, and so all of these things behave the same across all database systems. And so that's really easy and a great reason for using the EF core. Obviously, you want to write link queries, right? But link queries are not necessarily going to be the same across all databases. Now, it happens that the first three of these all have an appropriate dialect of SQL, and so EF Core will translate into the appropriate dialect of SQL for these two. We're going to show that in a second. For these three, sorry. The first two are relational. Even though the third one is actually a document database for NoSQL, the Cosmos team have put a SQL API on it, and so we can actually generate well-known link queries for the Cosmos database, but different from the ones we generate for relational databases. MongoDB, on the other hand, is completely different. It doesn't have SQL at all. It uses Mongo query language. So when using EF Core against MongoDB, we're going to translate into Mongo query language, and James is going to show that a little later. Okay, so I'm going to go quickly over to a demo now. And what I've got here, don't worry too much about what this DB context stuff is if you haven't seen it before, because James is going to look at that as well later. But basically, I'm going to run this link query, and I'm going to run it against SQL Server, Postgres, and Cosmos. So the first time I run it, it will run against SQL Server. It's a little hard to see the output once it starts here, but don't worry, because I've got the output again on the slides in a minute. So you can see here we've got a fairly idiomatic link query, SQL query, sorry, for SQL Server. It's got things like the square brackets that you would expect on SQL Server. If we now change the provider to Postgres, we should get something very similar, because they're both relational databases, so they're both doing basically the same thing. And indeed, you can see we do. We get a select, and this time we've got double quotes because that's more idiomatic for Cosmos, but other than that, it's basically the same. They're not always the same. Sometimes we translate very differently on Postgres compared to SQL Server. We'll see a little bit of that in a minute. Okay, but we're going to run that same query against Azure Cosmos DB for NoSQL now, and you'll notice here that this is actually quite a different query than the ones we had before. Let's go back to the slide so we can see that easier. Okay, so this was our link query. Basically, any customer whose region is Europe, so European customers. In Azure SQL, we have a query that does an inner join on the customer details table and brings back the information that way. Postgres is basically the same, like we said, but with Postgres idioms rather than Azure SQL idioms. And then on Azure Cosmos DB for NoSQL, we've got this different query. And that's because there's no inner join, because on Cosmos, on a document database, we're not joining against another table. That's because EF has nested the details information into the document. And so we're digging into the details and region to do this query. We're going to come back to that in a little while when I show you the mapping. So keep that in mind. So the bottom line here is that for link queries, we generate different queries in different languages depending on what the database system is. Okay, so let's talk about collections of primitives. So what do I mean by collections of primitives? Well, primitives is a very overloaded term, but in this case, I mean things that the database understands: date, time, strings, ints, that kind of thing. Collections, I mean lists like this or arrays. So basically, I've got an array of date time here, which are timestamps for when somebody visited. That's what we're talking about. The mapping of these is actually very different to documents, and then to Postgres, and then to Azure SQL. And actually, if we were going to start at the bottom here with documents, because mapping lists of collections of primitives to documents is super easy, because documents have this structure built in. Now, I've used a JSON representation here, but if it's BSON or whatever else, you basically have this structure in document databases. So it's a simple one-to-one mapping. Postgres doesn't have a one-to-one mapping, but it has a direct support for arrays in Postgres. So I can put an array of values into a column in Postgres, and we'll look at that in a second. So when we create so in this case, the mapping involves creating a table where the visits column is the appropriate type, and then it has these square brackets on to indicate its array. If we're going to Azure SQL now, it doesn't have the native arrays, but it can support embedded JSON. So in this case, we map it to embedded JSON. And in this case, the column is just a string column. But it's not just a string column. And this is a very crucial piece of this whole topic here. EF is fully aware of what the model here is. It's fully aware of what the mapping to the database is. So this is not a black box. EF knows that even though this is a string column, what it actually is a JSON array of date times, right? It's a JSON array of timestamps. And so it can write queries that take advantage of that. So I'm going to go back to my code here for a second. And I'm going to copy and paste in a slightly different query. And then we're going to run this against, we're not going to do Cosmos in the sake of time, but we're going to run it against Postgres first. Okay, so what this query is actually doing here, it's actually taking the data out of that visits column, which is an array, and so it uses unnest here. Again, I've got these on the slide, so we'll look at these queries again in a second. If I run it against SQL Server, it's going to look similar, but it's going to have an open JSON there instead of the nest, because on SQL Server we've recorded that into JSON. Let me go to the slide so we can see this easier, and I can make a point about it. Okay, so this is our query, link query again. So in Azure SQL, we've got OpenJSON, and in PostgreSQL, we've got unnest. Okay, so this is because Azure SQL is using a embedded JSON, whereas Postgres has native array types. But in both cases, EF knows that that is either an array of date times or it's a JSON array of date times, and so we can use a JSON to get datetime 2 out of it, to get datetime 2 out of it, and then do specific things in the query that depend on that being datetime. So this column, as far as EF concerned, is now a very fully supported queryable part of your database, even though, as far as SQL Server concerned, it is just a string column with JSON in it. Okay, so now we're going to get onto something where the difference between document databases and relational databases is quite dramatic. This is, if you want to go into more details on this, I covered this in our .NET Conf talk last year, so you can go check that out for a bit more details. But basically, when you're using a relational database, EF is going to denormalize each of your types, so customer details, and so on. And this is a gross oversimplification, but it's going to put it into different tables. So it normalizes it and puts relationships with column keys. That's not great for a document database, right? In a document database, we would much rather nest things that are appropriate under the child document to co-locate all that information together. So the idea with a document database is, okay, where we can, let's co-locate the customer with all its information into one place. So what this means is that if you're on a relational database, we're going to map these 4 entity types, customer details, address, and phone numbers, to their own tables. And each row of these, each row of the customer table has one customer in it. Each row of these other tables is joined to the row in the customer table to give you all the information for a customer. So if you want everything about a customer, you need to get and join together information from 4 tables. In a document database, so in this case, we're doing Azure Cosmos DB, all of the information is saved into individual documents for each customer. So I have one document per customer rather than having a single customer split across multiple tables. So this co-location of of data into Cosmos, into the co-location of data into the document, is a very important aspect of making sure that you're using a document database effectively and to best practices. You definitely don't want to create different documents for all these things. Remember that query we had, and I said that looks different. Now we can see why there's no inner join and this query looks like it is. So actually the region here is embedded inside the details. So this is our customer document, and what this query is saying is get the details, inside the details, get the region, see if it's equal to Europe. And so we have this query that's going to query without joining anything against one document and pull out only the ones that are in Europe. Okay, nearly at the end of this stuff, so you're nearly at the MongoDB demo time. But I'm going to talk about a final area of problems that people have when using data access, and that is schema management. So on a relational database, you need to modify the schema in order to evolve the model, either using DAC packs or EF-core migrations or whatever, right? So that's relational. On a document database, that's not going to work. There isn't a fixed schema. There is a schema. There is a model. I mean, this is something that is it's not a free-for-all inside a JSON document in general, inside a document database, but it doesn't have a DDL query language that defines it that you update with migrations or anything. And so there needs to be different patterns here. And this is something that EF Core is not currently able to do, but this is where we're going with it, which is to build in patterns that will allow you to evolve documents in the same way that you can change schemas for relational, but in a way that makes sense for documents. So for example, it could be that a document gets a new property, and when you load a version of an older version of the document, we automatically set some default value for that new property in the document or something like that. And there's lots of other more complex things there. I'm going to do a quick demo of Aspire, because we all love Aspire right now. This is intentionally very quick because there's other talks on Aspire that you should go check out, and we also did a community stand-up which shows some of this. But I've added SQL Server and Postgres to my Aspire app, and so I'm going to run it. Here we go. So it's starting up, and if you know anything about Aspire, then you should know that it was, oh, it's not started. That's okay. We will run it again. I have confidence that if we do it again, we'll get a better experience. Indeed, we're running. And I can pull this over here now, and you can see the Aspire dashboard. And you can see we've got Postgres and SQL Server. I've actually wired up your beautiful weather forecast thing to pull data from two databases. It's pulling this data from Postgres and SQL Server. And if we go back to our dashboard, we can see we've got console output for the queries. We can see that's also showing up in the structured logging. And if we go into metrics, for example, we can go and look in our service and see we've got nice database metrics coming out there. So lots of cool integration for EF Core in Aspire. That is basically what I have to show. So I think we are now going to hand over to James to talk about MongoDB.
Thanks, Arthur. I will be demonstrating the entity framework provider for MongoDB, something that we've been working on in collaboration with Microsoft. So as Arthur mentioned, documents are stored in MongoDB as nested BSON, which is basically binary JSON. You can see an example over here in Compass on the right, where we have a movie entry. We're going to be creating MongoFlix. We've got a movie entry, which has a plot, the genres, the runtime, the title, all of the interesting information all stored together inside of a single document. I'm going to go ahead and add the MongoDB.entity framework core package, which is going to bring in dependencies for both Entity Framework 8 as well as the MongoDB driver, which our provider is built on top of. So now that we've done that, let's jump over to our IDE. And the first thing that we're going to want to do is start by creating a database context. So our movies context is derived from the DB context, which ships with Entity Framework. And it is going to have a DB set of movies. Movies are our business object. And we are going to configure it. The key part is this use MongoDB. That tells Entity Framework to use the MongoDB provider rather than Postgres or Azure SQL or Cosmos. And we configure this with our Mongo client, which we'll talk about in just a second, and the database name that we're accessing data from. The other thing here is create a private constructor that just passes that options array, that options object into the base class, which does all of the wire up. The last thing that we're going to want to do is configure conventions. So by default, MongoDB often uses camel case for element field names, whereas C# uses Pascal case. So we can actually create a camel element name convention and add it to Entity Framework's convention builder, and it will sort out the different casing of the names. So with all of that in place, let's shift over to our program. So the Mongo client is the database client that comes with the .NET C# driver. So we're going to just create it and then create the database. And from there, let's go ahead and configure that DB context with that factory method. So created our DB context, and then we can execute a link query against the movies DB set. We're going to find all movies where the genre is comedy and the title starts with the letter A. And then we're going to order it by descending year. So let's go ahead and run this. You'll also notice that we're going to take the first 5 movies rather than the full list. All right, this is running. And there we get our 5 movies, all eyes and ears, an Italian name, etc. So this allows us to actually query data from our database and display it using Entity Framework. Note that the only thing that we had to do to make it work with MongoDB was that use MongoDB when we were creating our database context during that configuration. One of the reasons that we configure it with the Mongo client is because Entity Framework is good at data access, but every database has its own admin functions. So MongoDB is no different. So for instance, if we want to look at what query was executed, we might want to index it. Let's find out what query we need to index first. So let us jump over to the DB context, and I'm going to pop open this logging section. So all I'm going to do is log to the console. We could do log providers, much more complicated things. So I'm going to run the application again, and let's look at the query that is actually being run against MongoDB. As Arthur mentioned, we render it out to MQL using our provider rather than SQL. So we're going to get much more data out here because we are logging all of the context creation. But you'll notice here, right in the middle, we've got this movies.aggregate. So we are looking for matches against the genres and the title. We're sorting, and you'll also notice that even the limit is going back to the database. So we're only sending back the data necessary to satisfy this query. Now, like any database, it's really helpful to have all of our queries properly indexed, especially our mainline queries. So what we're going to do here is we're going to come down and go ahead and use some C# driver code. So we're going to create a new index model that defines an compound index using title and genres, both ascending, and we are going to create that on the collection. So let me move this up to the top so that we are ensuring that the indexes exist. Typically, this would be done in a deployment function, but for development time, it's often useful just to be able to set up a database and make sure all the indexes that are necessary are in place. Before I run this, I'm going to come over here. I will look at my indexes that are defined. We'll see there we have an ID index and a full text index. So let's go ahead and run now. It's going to actually create the indexes and then rerun the query. The query is going to be much more efficient now because we are leveraging an index rather than having to do a full collection scan looking for matching documents. And if we come over here and refresh, we can see that that index that we created using the management functions inside of the .NET C# driver has actually gone ahead and created that index for us. The other thing that Entity Framework provides is the change tracking functionality. So I can go ahead and I can create a new movie. And you'll notice that we have a new property that we added. The schema is, we know what the schema is because it's defined in our model, but I want to add in something new. So let me come over to movie, and I'm going to add in the book was better property. And I want to go back to here. So we're going to go ahead and we're going to create this new entity. We're going to associate it with the context, and then we're going to save changes. I'm actually going to set some breakpoints in here. And I'm going to let's go ahead and add in some breakpoints here just so I can show you the functionality of the context, that change tracking behavior. So we're going to create a new movie, associate with the context, and then we're going to save changes, and we're going to see what happens. There we go. Okay, so we're going to go ahead and create that new movie. We're going to add it to the context, and we're going to save changes. You'll notice that we've got this new field that we created, the book was better, and I'm going to jump over and look for the book was better with the value of true, just so we can only find that new document that we added. So you'll notice that it has a single genre which is a documentary. It's rated A for awesome, and it was put out in the year 2023 and has received no awards. We realized that we've made a mistake here, and that the movie actually came out in 2024, so we're updating a scalar type. We're adding a new genre to that nested list of scalars, that genre list, it being a true story, and we're going to add in the awards record. And we're going to go ahead and save changes. This is actually going to send a diff to MongoDB. It's not going to send the entire document. It's going to only send the pieces that changed, so that can be found and updated. And here we can see the genres. True story was added. The year's now 2024, and it's received 42 nominations and 42 wins. That shows us being able to selectively update documents inside of MongoDB. The last thing we're going to do is we're going to realize that we don't want this document anymore. We're going to remove it from the context, save changes, and if we find again, that has been deleted. So we can perform basic CRUD operations on complex documents, including nested types, including nested arrays. Those arrays can be of primitive types, such as date times, integers, or strings, or they can even be complex entities, such as we could have an array of awards and have those all stored within that same document. With that, I'll pass it back to Arthur.
Okay, thanks, James. That was really cool. It's great seeing things like the logging there that we implemented being used to log out MQL instead of SQL. It's really awesome. Good stuff there. Okay, so next we're going to really kind of change gears. So Shay and other people on the team have been working really hard on bringing AOT and precompiled queries. We're still hoping to get something experimental in EF Core 9, and Shay is going to give us a nice demo about all the work that they've been doing on that.
Thanks, Arthur. That was really cool stuff. And now we'll talk about something slightly different. So my name is Shay Rojansky. I also work with EF with Arthur on the EF team, and we'll talk a little bit about EF and native AOT. So first, a quick refresher on what native AOT actually is and why you should care about it. So native AOT is basically about compiling .NET applications ahead of time to a final binary. So there's no more just-in-time, no more JIT compilation. That means that .NET starts to function a little bit like, languages like C or Rust, where you don't have this startup JIT phase, but rather what you get is an end binary that you can just launch as is. Now, why would you want to do something like this? What is the reason here? So there's mostly two goals. The first thing is a quicker startup time. So because we don't need to JIT all that stuff every time we start the application, our application starts a lot faster, right? Which is a very cool thing. It's important, especially for cloud native applications and various serverless, for example, workloads where you want things to start very quickly so that you can serve your first customer very, very quickly, right? Also, maybe for mobile applications where you want things to be very, very snappy, and so on and so forth. The second nice thing that you get from native AOT is a smaller binary. We basically trim away everything that you don't need, and what you get is a very small kind of binary, which helps with deployments and managing containers, and again all that stuff that you do with microservices and cloud native applications and so on and so forth. So what is the state of things as of .NET 8? .NET and ASP.NET are largely native AOT compatible with certain restrictions. So in general, you can't just take any .NET application and just make it run in native AOT. You may need to make certain adjustments, and that's improving with time, and the .NET ecosystem is adopting it, libraries adopt it, and so on and so forth. So what about EF Core? This is, of course, what this segment is about. So we will here concentrate on the EF query pipeline kind of side. So what happens when we do link querying and how that can be made compatible with native AOT. So let's jump in. First, a very, very high level kind of overview of what happens when you use EF to execute a link query. So everybody, every EF core user knows what this generally looks like. You have a link query there with the where and the two-list spacing and so on. And what EF core does is it translates that into SQL and then executes that against the database. In other words, if we start looking at the actual pipeline inside, our input is a query tree, so a tree, abstract syntax tree representation of your link query, right? We get this as input, and then we pass through a pretty heavy process, which we call compilation. There's a lot of analysis and processing and all kinds of stuff in order to produce that SQL at the very end of it. And it's important that this is a heavy process, of course. You'll see why in a second. Out of this compilation process, we get two outputs or artifacts. One is, of course, the SQL. Of course, everybody knows this. But the second thing, which people sometimes don't realize, is that we also have to create something called a shaper or a materializer, which is a piece of code that will read the results coming back from the database. We sent the SQL, we get the results. Something needs to read those results and materialize blog instances out of them, which is what you, the developer, want to do, right? You want to get blogs from us. Right. So now, what are the problems with this scheme when we want to talk about native AOT? So the first problem is that this compilation thing, as I just said, is a very heavy process. So as we start up, this compilation will slow us down, right? Every time we run the application. It's long enough, it's heavy enough that even if you forget native AOT in normal EF core mode, we have a cache in front of it. That's this query cache that you see here, so that the second time that we run this query, we don't have to recompile it. That would be very slow. So the first time we compile it, the second time we just jump directly. In native AOT, we don't want that compilation at all because, again, it slows down our startup, and the whole point is to get rid of it. But the second problem is even more severe. That shaper materializer that I told you about is code that we generate at runtime. EF does this to create code that's specifically tailored for this query. So in this case, EF analyzes this query and it sees that it needs to return blogs. So it generates code at runtime that will read the results from the database and give you blogs. But we cannot do this in native AOT. You can't code generate stuff at runtime. There is no JIT, right? So we've got a problem on our hands. What's the what's the solution? How can we move all this out of runtime is basically the question. So at this point, I'm going to talk about a new C# 12 feature, so introduced at the same time as .NET 8, called interceptors. Interceptors are not something end users generally need to care about. This is more for people implementing stuff like what I'm doing here, what I'm demoing. It's not really an end user feature, but it's very kind of interesting. So I'm going to go very quickly into it. Interceptors very simply allow you to replace one method call or invocation. So it's that toList async here that you see is going to be replaced with something else. We tell the compiler, swap around, this toList async. Actually, don't run toList async. Instead, we have this other method here, this query1 toList2, which has this special attribute on it called intercepts location, and that it gives the file, the line number, and the column of something that is going to intercept or replace. And we can use that to basically replace your toList async with something else. So, okay, that's interceptors, right? But what is the overall plan here? Like, how are we going to do this? So the name of the feature is called precompiled queries, what we're now going to see. I'm going to demo it in 1 second. The plan is this. We're going to go over the user's source code, your source code, and we're going to statically analyze it. So we're not running it. We're just statically analyzing your code and identifying EF link queries in your application. For those queries, for each link operator, we're going to generate an interceptor that's going to replace it. So we're going to kind of completely replace that whole thing, that whole chain of operators. We're going to kind of set it aside via an interceptor and do something else. Finally, for the last operator, the toList async, the interceptor, so that's the operator that actually causes the query to be executed, right, against the database. So what we're going to do there, that interceptor is going to simply contain that SQL that we need to send to the database directly in that source code, as well as the code that reads the results back, the shaper, the materializer. So everything is going to just be there for us to run. But I've really talked enough, so let's switch to a demo. Code is always much more convincing than anything else. So what I have here is a very, very minimal C# program. You can see we've got our EF link query here. We've got blogs, the same query that we saw before. Everything is very simple. A blog has an ID and a name. The only thing worth mentioning here, if we concentrate on the configuration, is that we're configuring EF to log 2 specific events. This is something we can do. EF has a very cool logging configuration system. So we're interested in one event called query compilation starting, which is that big thing that we talked about, compilation. And the other event is command executed, which is when a command actually gets executed. So I'm going to run this quickly, and we're going to see what this looks like when it's executed. Remember, there's no native AOT, no precompiled, nothing. This is a normal standard thing. Just as a baseline for us. So this is going to start running now. And there we go, we have it. So the first thing we see at program startup is compilation. That's what we've been discussing before. This is that the first time we execute a link query, it has to be compiled, which is this heavy thing we're trying to get rid of. And the second event that we see here is the execution. So nothing really surprising. Okay, in order to demo this, the precompiled feature is not yet done. There's a lot of work still left. So what I did is I put together a small different program that's going to do the whole process. So I'm going to launch that. Doesn't really matter. This whole thing is basically going to run when you publish your application in the end version of this feature. So we're now running this thing, and what it does is it's loading my project, the test project. So the main thing that we just saw, it's loaded, it's being compiled, it's being analyzed, and lo and behold, we have here the exact same query compilation starting event that we saw before. So we moved it from runtime to this thing, which will run at publish time, right? The same thing we see, it figured out that there's a link query and so on and so forth. And what it did, and this is where the magic starts, is it dropped this file into my main project called EF generated interceptors. The exact details are going to vary in the end version of this, so don't pay too much attention to this. I'm not gonna go too much into this, but what you can see here is we generated code, we dropped code that has an interceptor for the where operator and for the toList operator. Okay, without going into the actual code, I'm going to do this in a second. I want to go back to my program, which hasn't changed in any way, and I'm going to run it again. So remember, we ran this program 2 seconds ago, and we saw those two events, compiling, executing, and now we're going to run it again after this interception file has been dropped into my project. And let's see what happens. It's going to take a couple of seconds, hopefully not too long. There we go. I think we're ready, and it's executing finally. Okay, and now you can see that we see the same execution event, but of course something here is missing compared to the last time, and that's the query compiling event. So that is exactly what we wanted to do. We basically took query compilation out of runtime, and we did it before that earlier. I do want to take a small peek into this file. So remember, this is plumbing. This is not stuff that any user is actually supposed to look at. It's internal EF plumbing that we generated and so on. But what's cool to see here is if I go here and I kind of go to the right, you'll find the actual SQL embedded in the code that's generated, right? So when you run that toList async, it already contains the SQL that we're going to send to the database, which is pretty cool. And if we go even more down, then all this is the code of what I called before the shaper or materializer. And indeed, you can see here the instantiation of a blog, the user's blog, and then we get the ID from the database, and we set it on that instance. And then we get the name, and we set it, and we give it. So this is the materializer, basically, and it's all there as C# code. Nothing needs to be done at runtime anymore. It's just there. So that's super cool. I'm now going to switch back for a very quick discussion of this thing, before I wrap up and give things back to Arthur. So what you just saw was precompiled queries. This is not yet native AOT. Native AOT is a larger thing which we're working on. This is one subset of it for the query pipeline. No matter what happens, this is going to be an experimental feature for 9. What you just saw includes, this is a very complex feature to implement. It takes, unfortunately, more than 1 year to really complete this. So I hope that we release something that's workable and already good for people who are willing to experiment. And in 10, hopefully we get something that's really completely stamped production ready and so on. Now, even when it's production ready, there's likely going to be various restrictions. We're not yet sure about them. Not all inquiries can be supported. So one notable thing that in 9 is not going to be supported is dynamic queries. So what are dynamic queries? Link allows you to compose its operators like order by and where, however, in whichever way you want, which is a pretty cool feature. In this specific code, you can see that we're doing order by, and then based on some filter variable in C#, we're going to either compose the where or not compose the where. And finally, we're going to execute the query. Now, in static analysis, there's no way for me to, for us to understand which SQL needs to run, at least no simple way, let's say. So unfortunately, at the very least for 9, this sort of thing is not going to be supported. But in many cases, it turns out it is possible to rewrite this kind of thing as 2 queries rather than as one dynamic query. And if you can do that, and if you want to do that, then you can use the precompiled feature. One last cherry on top that I want to focus on, and then I'm going to wrap it up. So one thing about EF is you write your link query, right? And it compiles. There's no syntax problem. You compile it, you run your application, and maybe you will get an exception from EF saying, actually, I can't translate this. And it's been a recurring theme. Users have asked us, I want to know about this earlier. I don't want to find out about problematic queries at runtime. I want to be able to know earlier that I have a query that's not going to work. Now, since this feature of precompiled queries moves the compilation earlier to the publishing step, you actually get that. So if you publish your application with precompiled queries, you will get errors about problematic queries at that point, and you can fix it. So this is sort of a fortunate side effect that we didn't even have in mind when we started working on this. So pretty cool, if you ask me. That's it. I really look forward to seeing people experiment with EF precompiled queries and getting your feedback on it, and I hope you like it. And back to you, Arthur.
Okay, great, Shay. That was really cool. Okay, so let's have a summary of what we've talked about today. So we looked at EF Core and showed how it provides common patterns for you to get the most from your databases. But critically, what EF Core is attempting to do is expose the power of the underlying database system. And so we saw there with James's demo on MongoDB how EF Core is able to do things on Mongo that make sense for Mongo. Such as creating different mappings, creating different queries to take advantage of the database system. In EF Core 9, what we're working on, well, we're tackling hard problems with AOT and link, as you saw in Shai's demo there. That's some pretty difficult stuff. And we're continuing this journey that we started going into combined relational document mapping. I talked about this at .NET Conf last year. Community Standups has some more information on this if you're interested. There'll be a link in just a second. And also, we're working with partners like MongoDB to bring new providers to EF Core, which is also always really cool. And remember, embrace your database. You want to use it to the best of its abilities. Okay, so thanks for watching. Giving credit where it's due, we've been showing the work of the .NET Data team at Microsoft, which is Andrew, Shay, myself, Yishi, 𝗦𝗽𝗲𝗀𝗀𝗃, Sam, and Luis. And we've also been showing the work from MongoDB people, and that's Damien, Robert, Ole, and James. So thank you guys for all your hard work there. And here's some links to find out more information. So we've got really extensive documentation on what's new in EF8. So if you're just coming up to EF8, then check that out. There's loads there. EF9, we've just started the documentation on that, but there's already quite a number of features documented there, and we've got previews and daily builds you can use. The community stand-ups are live streamed about every 2 weeks on YouTube and Twitch, and we go into deep dives into a lot of this stuff on there. So if you want more information, that's a great place to go find it. That's a link to our docs site. There's the EF Core code, open source, obviously, on GitHub, and also the MongoDB provider code is also on GitHub there. And then I've got a link there to the MongoDB provider documentation. So thanks very much for joining us, and we hope you enjoy the rest of Build.